T10.4. We want to construct a one-sample T interval for a population mean using data from a population with unknown shape. In which of the following circumstances would it be inappropriate to construct the interval based on an SRS of size 14 from the population? Okay, so this question is really aimed at getting us to think about the conditions to construct a confidence interval. Okay, so there's three conditions that we normally check. The first has to do with randomness. So usually we check to see if the data come from a random sample. The second condition is the 10% rule. Right, so is the sample size less than 10% of the population size? And the third one, which I'm guessing this question is going to be focused on, is the normal / large sample condition. Okay. Now there's three possible ways that we can satisfy that last condition. Okay. Option number one is if we know that the population distribution is approximately normal. Okay. I don't think that's an option because it says the population has an unknown shape. Okay, so I'll just put an X through that. Option number two is if the sample size is at least 30, then we can use the central limit theorem to satisfy this condition. Okay. That doesn't look like an option either because it says there's only 14 values in the sample. So option number three is we would need to look at the sample data, so like a dot plot of those 14 values. And the sample data should show no strong skew or outliers. Okay. So I'm guessing that we're going to have to read through the 5 answer choices and so we're looking for one where it would be inappropriate. Okay, so if this were to be violated, then that would lead to an inappropriate situation to construct the interval. Okay, so option A, a stem plot of the data is roughly bell-shaped. Okay, so if it's bell-shaped, then it's probably doesn't have strong skew because bell-shaped symmetric. It doesn't mention outliers. So that sounds like an appropriate situation. Okay, option B, a histogram of the data shows slight skewness. Okay, so slight skewness is not the same as strong skewness, so that situation seems to be appropriate. Okay, option C, a box plot shows that the values above the median are much more variable than the values below the median. All right, so remember a box plot is something that looks like this. Okay, the median is the value here in the middle. So if values above the median are much more variable, that would mean that they're much more spread out. So if this is our median, right, we have a lot more spread above the median and a lot less spread below the median, right, which would lead me to believe that it's skewed to the right. Okay. Now it says much more variable, so that would probably imply strong skewness. Okay. So currently I'm going to put an X there. I think that situation, because of the strong skewness, would violate that last condition. Okay. Choice D, the sample standard deviation is large. Okay. Well, that in and of itself doesn't violate the condition, right? The standard deviation doesn't tell us whether there's strong skew. It doesn't reveal if there's any outliers. So there's nothing there that's a clear violation. And then choice E, the sample standard deviation is small. Again, the size of the standard deviation doesn't tell us anything about skewness or whether there's outliers or not. So there's nothing really there that violates. But C, I think, is going to be our choice. It's implying that there's some strong skewness.